Okay, so we're back where we picked up, or left off at. Okay, so here's another example problem. And they even tell us, pick any 2 points on the line, change in y over change in x. So using change in y over change in x, all you have to do is use the table. But that's not necessary because you can also do rise over run, which again only means change in y over change in x. So if we do want to use the table, the graph, let's choose 2 points. So I wouldn't pick that one because it doesn't neatly intersect an x coordinate and a y coordinate. I would pick this one and this one. Okay? That one looks like it's nice and neat, and it'll give us a whole number, not a fractional number. So I'm going to go straight up from this point to calculate my rise, then go horizontally to calculate my run. So doing that, I see that my rise is, I go from 3, change in y, so 3 to 6 is 3. And then my change in x is, I go from 2 to 4, so that's 2. So my change in y was 3, change in x was 2, so that's my slope, or my m, because m means slope. Easy enough, right? Alright, on to the next slide. So they simplified the fraction, or they actually divided 3 by 2, and they got 1.5. So in this problem right here, so sometimes it's good to explain what the slope represents. And in this scenario, the slope means the plant grew at 1.5 centimeters per week. That's what it means right here. And if you want to have a nice little cheat, you can just look at week 1. And from week 0 to week 1, it grew 1.5 centimeters. So if your graph is going to be a straight line, it has to do the same thing every week. The slope's going to be the same from week to week. So you can just look at week 1 on any table, or whatever the table represents. Just look at x equals 1, and that'll let you know your slope. That may work most of the time, but sometimes it may not, so be careful. Here's another problem, and this one's fairly simple. It's basically the same thing as the last one. So using my little cheat, you can see that after 1 week, there's been 50 pages printed. And as you can see, as you go from each X, it increases by 50, so it's the same. And you can also use the graph if you wanted to. Well, it's basically the same as the last one, so not much more to say on this one. It's fairly basic. So here we know that 3 feet is in 1 yard. This one's even simpler than the other ones, but you can also use the table or the graph. Find your change in y over your change in x. So we see that our change in y, and here's another reminder. So your bottom table will always be y, your bottom row, your top row will always be x. So if you see that our change in y is plus 3, so we can go ahead and put 3 as our numerator. Then it'll be divided by our change in x. And then looking at these, we see our change in x is just plus 1. So 3 over 1, or just 3. And you can do the same thing using these points. Those points that are given to us on the graph. So more basic stuff. And this is more the same. This is your y2 minus y1 and your x2 minus x1. But instead of being given 2 points, they gave us, let's count them. They gave us 1, 2, 3, 4, 5, 6 ordered pairs. So this is the same thing as finding the slope from a graph. You can use any 2 points, but instead of being represented on a graph, they give you the exact numerical coordinates in the form of a table. So again, you can use any 2 points. So let's use these 2 points right here, 4 and 14, 2 and 10. And you don't even have to remember, so if subscript, the little numbers next to the x and y's, if that confuses you, don't even think about it that way. Slope is just change in y, so change in y coordinates over your change in x coordinates. No matter which way, order, fashion you do it, you'll always get the same answer. So let's use these 2 points here. So I'm going to go ahead and write my fraction bar. So change in y is my numerator, so let's look. I'm going to use my second one minus my first one. 14 minus 10 is just 4. Alright, now I'm going to find my change in x's. So now I'm going to use 4 and 2. 4 minus 2 is just 2. So now I have 4 over 2 up here. I'm going to reduce that, and 4 over 2 just equals 2. So the slope of the line that this table represents is 2. So that's yet another way to, or another form that they might ask you to find slope from, in the form of a table. And this is just an example problem. If you'd like to work this, just go ahead and pause it. And here's another one. And the instructions are here in case you forgot what I said just 1 minute ago. And these PowerPoints are not mine, so if you like them, please don't thank me because they are Miss Moyer's. She is a wonderful lady, and she deserves all the credit in the world. So please do not thank me. I'm just piggybacking off of her good work. So lesson 4, slope-intercept form, identifying slope and y-intercept. Again, this is stuff we've already covered, but in case you didn't understand it the first time, or for whatever reason you missed, this is a great review. So let's go over it again. Okay, this is straight from the textbook. So Miss Moyer agrees with me on this and saying that the textbook, sometimes there's no other way to break it down any more simple than the textbook does it. So the textbook is a great resource. So if even in class time or these videos do not make sense to you, I recommend going through the textbook because sometimes it just doesn't get any better, any more simpler. All right, so let's read the definition. Linear relationships can be written in the form y equals mx plus b. This is called the slope-intercept form, and I would like to go ahead and say that makes sense because the slope comes first and then the intercept's last, and I'll say what I mean by that. When an equation is written in this form, m represents the slope and b represents the y-intercept. So if you look at the order that's written in, m comes first, which makes sense because it says slope. Slope's the first word in the name of it, and then intercept. So b comes second. B is the y-intercept always, and they even have it labeled like that down here. So anytime that we're looking at a graph, a table, or we're trying to make an equation from a graph, it's always going to come back to this form right here. And whenever you do that, whatever form of information they give you, you can always find the y-intercept or the slope. And I'll go through a couple of examples to show you how to do that. Let's look at this one, which they already did for us, but I'll go ahead and show you how they did it. Okay, so you can find the y-intercept from a graph just by looking at it. So it says B is the y-intercept. So we have to look at where this line right here crosses the y-axis, which is always up and down. And of course, just by looking at it, I can see that the y-intercept is right here. Right here. And I see what my y coordinate is at that place where it crosses, and I see that it's +1. So they replaced B with +1, or the y-intercept. And we already know how to find slope from a graph. We just do our rise over our run. So we can use that point I just drew, and we can also use that point. So let's go up and over. So if I go up, I see that my rise is 1, 2. I see that my rise is 2 units. I see that my run is 1 unit. Slope is rise over run, or 2 over 1, and that just goes to 2. So they replaced my m with what we just found was our slope, 2. And we didn't mess with our y and x because you use those on different kinds of problems. Most of the time you don't mess with y and x. They just stay the same. All we want to find is our slope and our y-intercept, and then we're good. We've answered the question. So in this problem right here, no math at all is required. I know, right? You probably never hear me say that again. But it's true. So let's enjoy it while it lasts. And this is how you solve it. So looking at, or given this linear equation, so looking at the example down here, y equals 3x plus 1. What is the slope? So we're not given a graph or table or any kind of points. But using this equation right here, which describes a graph or describes a table, we can find the slope. According to this equation up here, m is the slope, and m is always right here in front of the x. So if we look at what number is in front of the x, including its sign, that's an important part, don't forget what sign is on that number, we can see that the slope is 3. So we would just say m equals 3, or the slope equals 3. Simple as that. And I do believe this is on the first homework I gave out as well. So let's go to the next slide. Just more of the same. So this is just a reminder up here. Up here on what means what, and then this is the actual example down here. So you're given this equation right here. You look at the number, including its sign before the x. We see that it's negative 1 over 2. So they say the slope is negative 1 over 2. And then you don't see anything going on behind the x. That's where plus b would normally be at. So we represent nothing by just writing the number 0. So we would just say plus 0. But we don't normally do that, so they just leave it blank. But leaving it blank is just the same thing as doing plus 0. So we just say the y-intercept is 0. The graph of the equation the graph of the equation crosses through the origin, because that is where y is 0 and where x also happens to be 0. So simple enough. Here's another one, pretty simple. 4 is the number in front of the x, so that's our slope. And then we have a minus 5 happening behind the x. That's the same thing as just adding plus negative 5, so it looks more like the original equation up here. So negative 5 is our y-intercept. Simple enough. And this is important to know because they can give you the slope and the y-intercept in here, and using this information we'll make graphs. We'll be able to actually plot this equation onto a graph, or form a table too. And these are some easy example problems on here. There is one example I don't see. So they showed you what you do with y-intercept. Like for this one, when there's nothing behind it, you know it's just plus 0, so y-intercept is 0. But what do you do if you have an equation like this, where there's no number in front of the x right here? Well, you just have to think about how many x's is that. That is 1x. So they don't write 1 in front of that x because they assume that you know that that's just 1x. So anytime you just see an equation where there's no number in front of the x, so on this one at y equals x plus 2, you would just say that m, or the slope, equals 1. So that's the only other really thing that it doesn't show you in the examples. Actually, hold on. There was one. And that was that one right here. This one down here. So you would just see that that's plus 1. So there's nothing going on before the x or after the x. So you would say for that one, you would say slope equals 1, y-intercept equals 0. And that would be how you do that one. So I'm at about 16 minutes right now. So part 3 will be lesson 2, graphing linear relationships and equations. So now we're starting to get into the meat of our unit.